1.5, measuring and constructing angles. Okay, so I've got an angle drawn here, and I just want to talk about how you can name this angle. So there are a couple of different ways. Some people might call it angle A, just naming it by the vertex. Now that's not a great way to name that because there might be, a lot of times in a diagram, there might be more than one angle A. Like, let's say we had a diagram like that. Well, then is angle A mean this, or the whole thing, or it could even mean the angle on the outside. So you can name them like that, but that's not a great way. A better way is to use um, 3 points. So I wouldn't call this angle ABC though, because when you're naming it with 3 points, the middle letter has to be the vertex. So the vertex, I didn't say that. I think probably no, but that's the corner of the angle. So point A here is the vertex. So I could call this angle BAC. And then if you read it, it'd be BAC. So it'd form an angle like that, BAC. Or you could call this CAB. But in both of these examples, the vertex must go in that middle position. Okay, so if you said angle ABC, that would be an angle that looks like that, right? Different angle, all right? And then sometimes there might be a little number inside the angle, and if you get something like that, then you can just call that angle 3. And this is my little symbol for angle, right, that I'm using here, okay? All right, next up, I'm going to use a protractor to measure these two angles. And I realized that I don't have a protractor at home. I feel like a bad mathematician, but that's the way it is. My protractors are all at school. So I just printed one out and cut one out. So if you don't have one at home, don't worry about that. The problems in your book are going to have the protractors printed on them, so you don't need it. But I just want to make sure you know how to use them. So first, I also don't even have a ruler here, so I'm gonna use my phone just to extend these angles to make them a little bit longer. Just gonna use this as a straight edge. Well, I can just eyeball it. Okay, so I'm gonna measure this angle first. So what you'd wanna do with your protractor, would work better if it were see-through, but it's not. But you want to set the vertex of your angle right in the middle of the protractor, okay? And then you'd want to set the straight edge on one of the sides of the angle, so something like that, okay? Actually, I didn't need to extend this one really. I guess it's worth having it extended right down there. Okay, so then I'm looking where this ends up. So it looks like it's right about there, okay? Now the problem here is that there's two sets of numbers. So it looks like it's either in between 40 and 50 or in between 130 and 140, okay? So what you want to do is look at the angle itself. So we can see that this is less than 90 degrees, right? 90 degrees would be an angle like this. So what we're going to do is use the smaller set of numbers, right? This is a 0-degree angle here, then 10, 20, 30, 40. So we're using the inside set of numbers here. And so that's pretty close to 45 degrees. It's around 45 degrees, okay? So this would be about 45 degrees. It wouldn't make sense for it to be 135 degrees. And then so same kind of thing over here with the second angle. I'm going to set it up like so. And then I'm thinking, okay, this is where my angle is starting, where the straight part that my protractor set along. So I want to start with the 0, 0, 10, 20, 30, 40, 50, 60, 70. It's more than 90, right? So I'm going. And so I'm using the inside set of numbers here again. And so it's somewhere between 120 and 130. It looks like it's maybe about 127 on mine. It wouldn't make sense for it to be 53 or whatever. So this is 127. It's more than 90 degrees. Okay. All right. So that's how to use a protractor. All right. Don't worry if you don't have one at home again. All right. Congruent angles. So often I'll use these kind of symbols to say congruent angles. So congruent segments have the same length, the same measure. Congruent angles also have the same measure. Okay, so that means if they have the same measure, well, these wouldn't be congruent. They don't have the same measure, right? But if the measure of two angles is equal, okay, when you see a little m like that in front of an angle symbol, this means measure of. So if the measure of angle A is equal to the measure of angle B, then angle A is congruent to angle B. So a little equal sign with a little squiggly above it, right? So those the angles are congruent, the measures of them are equal, okay? All right, now I'm going to talk about diagrams, how to mark congruent angles in diagrams, okay? So we've got clearly these two angles are congruent and those two, well, not clearly, but they are, right? So these two bigger angles are congruent. The two smaller angles are supposed to be congruent. What the book is going to do if they want you to know for sure that these two smaller angles are congruent, they'll just put a little swoosh in both of those, okay? So that's supposed to indicate that those two have the same measure. And if they want to show you that the second set are congruent to each other, but not congruent to these two, then they'll just put a second swoosh in both of those. And that shows you that, hey, these are a pair, these two are congruent, these two are congruent as well, okay? And nothing wrong with that. That's the way the book is going to mark congruent angles. I've got a slightly different method. I just think when you have just the swoosh, sometimes it can get confusing in a diagram. So what I like to do, instead of just the swoosh, I'm going to put a little tick like so to show you that those two are congruent. Okay? And then if I've got a second set of angles that are congruent, I'm going to go like that. Okay? Both of these methods are perfectly fine, and really you need to be familiar with both because I'm going to draw my pictures like that and the book's going to do it this way. Okay? All right, moving on. We're going to talk about classifying some different angles. So if you have an angle that looks something like this, so I've got an X in there just because it's an unknown measure. This is going to be an acute angle. Okay, and that just means that it's less than 90 degrees. A lot of people are going to say less than 90 degrees. Technically, it's really between 0 degrees and 90 degrees. And that might seem kind of silly, but you can actually have 0-degree angles and negative angles. And when we get into some trigonometry, we'll talk about that. But technically, it's between 0 and 90, not just less than 90. Okay, and for an obtuse angle, a lot of people will say, oh, that's more than 90 degrees. Again, there's a little bit of a technicality. It is more than 90 degrees, but it also is going to be less than 180 degrees. You can go past 180 degrees. Okay. All right. Then we've got, this is a right angle, and that just means we've got exactly 90 degrees. Okay, and this last one is called a straight angle. Okay, so it looks just like a straight line, except it's got that point in there. But a lot of times you'll see this kind of thing just to try to indicate this. This is supposed to be an angle that's just open flat. Okay, so this is going to be exactly 180 degrees. Okay, so a straight angle is 180 degrees. All right, so we had the segment addition postulate earlier in the book. Now we've got the angle addition postulate. It's the same kind of idea. So if we've got two angles that are stuck together like this, they're next to each other. So they share a vertex, and then they share a side. One of the sides is the same. Okay, we're going to use the word adjacent. These are adjacent angles. And it's really important to know what adjacent means because it comes up so often in this book. So if you know that adjacent means next to, that will go a long way, okay? And so just to make this easy, I numbered these angles. So I could say using the angle addition postulate that angle 1 and angle 2 added together are going to be congruent. Well, those are the two smaller angles. It's going to be congruent to the bigger angle, right? Together they form this bigger angle, so that would be angle ABC. Or you could call it CBA, but the B has to be in the middle because it's the vertex, okay? Likewise, since we've got congruent angles, then you can say the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle ABC, okay? So when you've got that measure of part in there, then you're going to use an equal sign. When you don't have the measure of, you're going to use the congruent sign, okay? All right. So let's try an example. Okay, so there's some given information which isn't totally filled out here. So the measure of this angle is going to be 102 degrees. Okay, so that's PQR. So let's make sure we read the diagram correctly. PQR. That's this bigger angle. So they're telling us that 102 degrees is this bigger angle. I'm just going to put that in the picture. Okay. All right, so now what we can do is use the angle addition postulate. These are adjacent angles, so these two angles added together must equal 102. Okay, so I'm going to solve for x. So I can write myself an expression. I can say, using the angle addition postulate, angle PQS plus angle SQR, those are the two smaller angles, are gonna, the sum of those two is congruent to the bigger angle, which is PQR. Okay, and now what I can do is I can substitute in the values. So I know that the measure of that angle is 7x minus 5 degrees. And the measure of SQR is 9x plus 11. And then the measure of the whole thing is 102 degrees. I guess I should really have the degree symbols. If you left the degrees, it's off there. It's not that important when we solve for x. They're kind of going to go away anyways. Okay, so now I could write this without the parentheses. It would look the exact same because we're just adding those two groups together. So I'm going to combine the like terms. So I'm going to add 7x and 9x. That gives me 16x. And then I'm going to add negative 5 and positive 11. That gives me 6. Okay, now I'm going to subtract 6 from both sides. Okay, and the last part I'm going to divide by 16. And 96 divided by 16 is going to come out to exactly 6. So that means x equals 6. X isn't 6 degrees. X is just this number because you can plug in 6 here and then figure out how many degrees that angle is. But x itself is just a numeric value. It's not. It doesn't have the units. Okay. And then when I'm looking for PQS, I want to make sure I get the right angle. PQS is this one, so I'm going to use 7x minus 5. So the measure of angle PQS is going to equal 7x minus 5. Now I know that x is 6. I guess again, really, I should put the degrees there. My answer here is going to be in degrees. So I've got 42 minus 5. And that's going to be 37 degrees. Okay. So solve for x, and then I solve for the angle PQS up here. Okay. All right. Next up, we're going to look at an angle bisector. Okay. So an angle bisector divides an angle into two congruent angles. I'm just going to use the symbols there. All right. So if BD is the angle bisector of this angle, and I want to show you that without writing it out, what I would do is just show you that those two angles are congruent. So if those two are congruent to each other, they have the same measure, and that means ray BD is cutting that exactly in half. Okay, so I could say ray BD is the angle bisector of, and then the bigger angle I could call ABC. Okay. All right, so let's try an angle bisector problem. This time we're told that BD bisects ABC. So that piece of info right there is telling us, hey, we've got congruent angles. And that's going to allow us to set up our equation. So now we can say 4x minus 6 must equal 2x plus 14. Okay, and then we can solve for x from there. So I'm going to subtract 2x. Then I'm going to add 6 to both sides. And divide by 2. X equals 10. Okay, so now we can find the measure of the different angles in this diagram. ABD, that's this angle, right? So that's going to be the 4x minus 6. And now I can plug in the 10 for x. Okay, I'm going to do the multiplication first. Okay, and now I'm going to find ABC, which is the bigger angle. Now, since these two are congruent, I just figured out that this is 34 degrees. So I'm pretty sure that this is also going to be 34 degrees. So you could just double the 34 to get the angle ABC. Just to be safe, I'm going to go ahead and find, I'm going to check this out and make sure that that does come out to 34. So I'm going to do 2 times x. X I know was 10 plus 14. And sure enough, this does come out to 34 degrees. So now I feel really confident that I didn't make a mistake on either part. So now angle ABC, I can use the angle addition postulate to say measure of angle ABC should be equal to the measure of angle ABD, the top angle, added to, and this, well, the sum of the top angle and the bottom one. The bottom one I'll call DBC. Okay, and I know the measure of both of these, so now I can just substitute those in. They're both 34 degrees. So then that's going to come out to 68 degrees. That's my final answer, and that is also the end of the lesson. See you next time.